All right, welcome to the last lesson. Yeah, right. No, this is not the last lesson of the book. This is not the last lesson of any... Well, it could be the last lesson that I teach you through video. I don't know. As I told you, I'm recording beforehand, so I don't know what's going to happen. But by now, obviously, this video is going to be released Friday, March the 27th, which for you guys is today. And so you guys already know whether or not we're going to go back to school or not. So I don't know yet. But today we're going to do the next lesson. And as you can see, I didn't really erase the board. And I know some of you might ask, why is it like different? Well, it's different because I'm using the front selfie camera. And so it actually flips the image, and you can't read this because it's flipped the other way. But that's neither here nor there. Today we're going to talk about surface area of right solids and the surface area of a sphere. So I told you needed to know. Yesterday I told you in the video yesterday I told you need to know area of triangles, rectangles, squares, and circles. And that's what we're going to use today. So let's get to it. Okay, so this is example 1. And because we're talking about surface area, I'm going to actually bring something that is going to help me a little bit to illustrate the point here. Oh, it fell. And it's not going to be exactly like this, but it will help me illustrate the point. Because what happens is that most of you see a shape like this and you think immediately volume. All right, so how much does it fit inside? But that's not what we're talking about. What we're talking about here is the surface. What if I wanted to gift wrap this? How much paper do I need? All right, so that's what the point is. The point is that we want to be able to get this side. So it has, this box has 6 different faces. So it has this one right here, and obviously the opposite, which measure the same. Then it has this part right here, which measures the same as this one. And then it has this part right here, which measures the same part as this one. So that is going to be true of all boxes. So what we're trying to tell you is not how much does it fit inside, but how much do I need to be able to wrap the paper. And so you have to have been thinking about area, not volume, not space inside, but surfaces, the surface that is around it. And that is the difference between surface area and volume. So for this particular example, we have this type of shape, which for most of you, because if you think about it, you're going to be like, oh, okay, this actually has a... I think I ruined it, but it doesn't matter. You guys can use your imagination. So in here, we have a base that's a rectangle, and then we have another triangle, and we have 3 rectangles, 2 triangles. And so most of you, when I ask you, okay, what is the base of this? A lot of you will be like, the rectangle. Wrong. The base is not the rectangle. What happens is that it fell. Okay? It was actually on the base, and then it fell. Because things fall. If I put this marker sideways, you're going to tell me, oh, the base is where it's laying on, right? So it's this. No. The base is here. But we usually lay them like that. Look, we lay them like that, even though we all understand that the base of the marker is this one. It's the same thing here. The reason that most of you get problems like this wrong, especially with this type of shape, is because you guys get so confused about the base. Well, the base of this particular solid is called a triangular prism, because it has 2 triangles opposite this shape, and they measure exactly the same thing. This is why this is the base and this is the base. Now, obviously in here, it's not going to matter a lot. I'm going to tell you why it's not going to matter. Because we have to find the base of 5 different surfaces. Of this one, 1, of the one in the back, 2, of the one in the bottom, 3, of the one in the back, 4, and the one in the front, 5. And I'm going to circle 5 so that you understand is the one in the front, like over here. So we have to find 5 surfaces to be able to do it. Because the first example says, find the surface area of the triangular prism. Okay, so good news for us is that 1 and 2, the 2 triangles measure exactly the same. So if I find the area of this triangle, I multiply by 2, boom, I got the area for 2 of them. Now, it's even better news for us because if we know the area of a triangle, the formula, base times height divided by 2, well, we're going to multiply that by 2 over 1. Look at that. The area of the triangle for both 1 and 2, for the first two things, it's just going to be base times height. And the base is 3 and the height is 4. So the area of the two triangles is going to be 12 centimeters squared. Okay, I already started to solve the problem, okay, because I'm going to make it as easy as possible. Now, this one right here is going to be 5 and 3 for the one in the bottom. The one in the bottom is 5 times 3. 5 times 3 is going to be 15 centimeters squared. Boom. Area of one of the rectangles. 15. So now I have two numbers. Now, I can do this one, 4 times 5. The one all the way in the back. 4 times 5. So 4 times 5 is going to be 20 centimeters squared. So look, I already did two triangles, one rectangle from the bottom, the rectangle in the back, and now I'm missing the rectangle all the way in the front, and it's going to be 6 times 5. 6 times 5 is going to be 30 centimeters squared. And then I'm going to add. This is going to be 50 centimeters squared. I erase the squared here and put it right here. And this is going to be 27 centimeters squared. When I add it to the 50 centimeters squared, I'm going to get 77 centimeters squared for the answer. Let's check with your book. And I got it absolutely 100% wrong. But I'm trying to figure out why. Isn't 6 that? Did I make a mistake with the measurements? Yes, I did a mistake with the measurements, and that's why it's really important for you to check. This is supposed to be 5, and this is supposed to be 6. Obviously, everything would change if that is true. Yes, that's what happened. All right, so I have good news and bad news. The good news is the triangles are still 12 centimeters squared. Yay! The bad news is that now I have to find the area of the three rectangles. So the first rectangle, this one in the bottom, is going to be 6 times 3, which is 18 centimeters squared. Okay, so yes, everybody makes mistakes. Let's just move on, right? Nobody saw it. Nobody has the evidence. And if you rewind, maybe it's because you just don't like me or something. So we have 30 centimeters squared for the triangles and the bottom rectangle. And then for the back rectangle is going to be 4 times 6, which is going to be 24 centimeters squared. And then for the top rectangle is going to be 30 centimeters squared because it's going to be 5 times 6. Yeah, my bad. I copied the triangle wrong, the triangular prism wrong. And that tends to happen when you just do videos back to back to back. You tend to make more mistakes as the videos start to pile on. So then 30 plus 54 is going to be 84. Isn't it 88? No, it's 84. I am right. 84 centimeters squared. Again, I told you, as you start piling on the videos, you start making more mistakes because it's hard. Okay, so it will be the first example of lesson 105 is going to be 84 centimeters squared for the surface area. So the surface area, again, is not what fits inside, not what fits inside, not what fits inside, but what goes outside. The different surfaces, so this is one surface, and as I said, this box has 6 surfaces. You have to add all of them together. And that will happen for everything that we do. So let's actually move to example number 2, which has a can of soup. Okay, example number 2. This is actually something that I'm going to use my bottle of water to show you. And I'm going to explain this the way that I've been explaining it for many years now, which is with the label of my water bottle. So what happens here is that we have a cylinder. And a cylinder is very unique in that it has only 3 shapes to make it. So it's a circle with a rectangle and another circle. That's it. That's all the can. So if you wrap the circle around and put it there, that would be it. So obviously, I know that you know how to find the area of a circle because we've been doing it, pi radius squared. And so this one also would be pi radius squared. And this one is going to be base times height, right? But there's something that is a little bit harder to figure out and see in one of these. And so that's why I have to do it like this, because you know that this was wrapped around the water bottle. And the water bottle is a cylinder. Right? And so what happens is that if you look at it, it's a rectangle, right? It's a rectangle. You can look at it this way, it's a rectangle. But then to make it into a cylinder, you wrap it around like this. And then in here, obviously, would be the circle, like around here, right? You see it? Let me see, right here. There you go. Right here goes the circle. Right here goes a circle, and right here goes a circle. Well, this part right here of the circle is the what? Not the area, but the part around the circle, which is the circumference. And so that's really important to understand, because when we put it like this, right here, something like this, it makes a perfect cylinder. And so this right here, this length, is going to be the circumference of the circle, because when we unwrap it, it's going to be a rectangle, right? But the base, we don't know what the base is. I mean, they don't even tell us the base based on the drawing from the example. They tell us that the height, this height is going to be 10 centimeters. And I know it might not be apt to scale, 10 centimeters. And then the diameter is going to be 7 centimeters. But they don't tell us what the length is. The base of the rectangle is, they don't tell us the base of the rectangle, and we have to find it out. So the base of the rectangle, it makes sense that it goes perfectly around the circle. Okay? So it goes perfectly around the circle. And this is why this part right here, the base of this circle, is going to be the circumference. The base of this rectangle. I heard myself say base of the circle. The circle has no base. It's a radius and a diameter. Anyway, the base of the rectangle will actually wrap around perfectly and make it into the circle, be the outside part of the circle, which we know it's not the perimeter of the circle, but it's the circumference. And so the circumference, again, is pi diameter or 2 pi radius. And you have to know these formulas. This is what I'm telling you. The hardest part of this is the formulas. After that, it's just multiplying and adding, which I hope by now most of you actually can do. And as you have been seeing in this video, I make mistakes multiplying and adding. That's why we need to all check our math. And that's why I tell you, check your math. All right. So let's actually get into the math. What is the surface area of the can? Now that we understand that the base of the base of the rectangle from the cylinder that we had here is going to be pi diameter or 2 radius pi. We're going to actually do it. Now, they tell us in this problem to use pi as 22 over 7. Okay, 22 over 7. So, step 1, I would actually find the area of both circles. Okay, so the area of the circle is going to be, area of circle is pi times the radius. The radius is going to be 3.5 squared. I don't know why they give you 3.5. It makes no sense to me, but that's what they gave you it. Pi times 3.5 squared, right? Yes. Oh, okay. But in your book, which kind of makes sense too, is they want you to think about this as 7 halves squared. All right, so if we do 7/2 squared, its area of the circle is going to be 22 over 7, which is pi, times 49 over 4. Right? Because we did this. And so in here, we're going to divide by 2. This is going to become 11. This is going to become 2. And this is going to become 1. And this is going to become 7. So the area of the circle is going to be 77 halves, or the area of one circle, by the way. It's going to be 77 halves, or 76 is going to be 38 and a half. I believe is 38 and a half, just for the area of one circle. Yes, 38 and a half centimeters squared. All right. 38 and a half centimeters squared. So this one right here measures 38, or not measures, 38.5 centimeters squared. It's the same thing. 38 and a half and 38.5 is the same thing, as you should all know. And so because we have two circles, we have to multiply that times 2. Well, what do you know? We already know that 77 divided by 2 is 38 and a half. Well, if I multiply by 2, it's going to be 77 centimeters squared. Boom. So I already have the two circles. Now I'm going to get into the rectangle. The area of the rectangle is going to be pi diameter, which is 7 by diameter, 7. Pi is going to be 22 divided by 7 times 10. Now, the area then would be 70 over 1 times 22 over 7. Yes, because I multiplied 10 times 7 is 70, and 22 over 7, I didn't do anything. Now, I'm going to cancel out the 7s, and this is a 1 and this is a 1, so it would be 220. Because 10 times 10 times 22 is 220 centimeters squared. Then I'm going to add that to 77 centimeters squared, and I'm going to get 297 centimeters squared. That is what I got for the surface area of this cylinder. And that would be what the book also got. So right there. This is how you do example number 2. All right, for example number 3, that's supposed to be a sphere. It's not supposed to be an apple. But, you know, just use your imaginations, please. So what happens is that you need to know how to find the area of the surface area of a sphere. And the surface area of a sphere, they don't even bother really explaining it much, but it is going to be, so surface area for a sphere is going to be 4 times pi r squared. That's what it's going to be, 4 times pi r squared. I guess one of the reasons is because if you actually get 4 circles and you saw them together and then wrap them around the right way, you will literally get a sphere. That's one of the ways that they do basketballs and they do baseballs, and they do, well, obviously not with circles perfectly because you know the shape of the baseball, right? And the tennis ball, it's kind of like this. And then it has parts other than that. But these 2 parts are actually circles, and then the other 2 parts that go in between are circles. So think about it that way. If you know what I'm talking about with baseball, if you know what I'm talking about with maybe tennis, they use the same thing. Maybe with basketball, a little bit, but not quite. The design of a basketball is a little bit different. It's not quite the same, but there's one circle, there's another circle, and then in between, there would have to be 2 other circles. And obviously, soccer balls, I'm not even going to start drawing one because it has changed so much. The design's changed so much that it's not even close to what it used to be before. So just know that the formula for the surface area of a sphere is 4 pi radius squared. Okay, so it all has to do obviously with the center of the sphere. If you cut it this way, it's going to be, if you cut an orange that way, like right through the middle, it's going to be a circle. And if you cut it this way, obviously it's still going to be a circle. So it has to do with the area of the circle. It has to do with it. And so in your example, they ask you to find the area, the surface area of a tennis ball that has a diameter of about 6 centimeters. So they say this is about 6 centimeters. And to use 3.14 as pi. So we're just going to use the formula. That's it. That's all we're going to do. So we're going to do 4 times 3.16 times 6 squared. All right, so that's going to be 4 times 3.16 times 36. We can multiply 4 times 3.16 and then times 36, but what I'm going to do is 36 times 4 and then that by 3.16. So 36 times 4. 6 times 4 is 24 and a 2 goes up. 3 times 4 is 12 plus 2 is 14, 144. So then we get 144 times 3.16. Oh, we missed Pi Day, by the way. That's sad. I usually do something. But it was going to be on a Saturday this time, so I couldn't have done anything anyway. 4 times 6 is going to be 24, and a 2 goes up. 4 times 6 is going to be 24, plus 2 is 6, 26. And the 2 is still up. 1 times 6 is 6, plus 2 is 8. 0, placeholder. 1 times 4 is 4. 1 times 4 is 4. 1 times 1 is 1. 3 times 4 is 2 placeholders is 12, and a 1 goes up. 3 times 4 is 12 plus 1 is 13, and a 1 goes up. 3 times 1 is 4, and that's it. So in here I get 4. In here I get 10, and a 1 goes up. So 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, and a 1 goes up. In here is 5, 4. So 2 decimal places, I got 455.04 centimeters squared. Let's see the book. Not even close. Oh, I know why. I made a mistake here. I said the diameter was 6, not the radius. The radius is 3. This would be 4 times 36. And so what I did was I multiplied this 4 times more than what I needed to be. So the area, the surface area would be 1, 11 right here. In 15 it fits 3 times. 12. And in 30 it fits 7 times. 28. And in 24, it fits 6 times. Yeah, so be careful. It's 3 squared, not 6 squared. Okay, as I told you, I've been doing math a while now. And so it's been hours and hours of math that I've been doing. So it's 113. This is what I got. 113.76 centimeters squared. Let's check with the book. They've got 113.06. 13. But they rounded down to 113. Yeah, 45 would be 44 and a 1 and a 5. Wait, if I multiply 36 times 3.14, what do I get? 6 times 4 is 24, and a 2 goes up. 1 times 6 is 6, plus 2 is 8. 6 times 3 is going to be 18. 0, 2, and a 1 goes up. Yeah, I'm going to get what the book says just by doing this. I don't know. Somewhere I made a mistake here, and that's why you check your math. 3 times 4 is 12, and a 1 goes up. 3 times 1 is 3, plus 1 is 4. And 3 times 3 is 9. Let's see. 4 plus 0 is 4. Plus 1 is 1 over here. 9 plus 4 is 3. And a 1 goes up. Yep. (113.4 centimeters squared). So please make sure that you understand what the difference between the things are, because it makes a lot of sense for you to make mistakes like that one, where you think that the diameter is the radius, just like I did, because I'm a little bit tired. So yeah, please don't make the same mistakes. I mean, I have been doing math for over 2 hours now, so don't make the same mistakes. And so understand that it was 3 centimeters squared. So this right here would be what gives you that, which is also the same thing as here. So in here, then we go to that. And that would be the answer. Disregard the rest, please. Okay? But now let's move on to the last example, which is a little bit tricky, actually. We'll see why. All right, the last example for this week is going to be this. And I know it's not beautiful as in the book, but, you know, use your imagination. So what we need to do is find the surface area of this thing. And so this thing is so complicated because this is a complex shape. It's a complex hexagon. And then we have all these little parts here. So we have to do 2 things. So we have to find this hexagon twice, because obviously in this side it has one, and on the other side it has one. Then in the bottom it has one long thing, one long rectangle going in the back. So I'm going to try to kind of like illustrate what I'm talking about here. And in here it has another rectangle. So it has 2 more rectangles, and then it has the hexagon in the back. So this one and this one, the good news is because this is 4 and this is 1, and because this is 4 and this is 1, I have 2 different rectangles that measure exactly the same. So it's going to be 4 times 1 times 2. All right, for the rectangle in the bottom and in the back. So that is going to be obviously 8. Okay, and the units is in centimeters. So we have 8 centimeters squared for the bottom and the back. Okay, now what about this one right here? Well, this is 2 times 2, right? Oh no, 2 times 1, sorry. 1 times 2. 1 right here in the base and 2 right here. So it's going to be 2 times 1. And then here on top, it's also going to be 2 times 1. 2 times 1. So we have 2 of those. 2 times 1 is 2. Times 2 is going to be 4 centimeters squared. And then I have 2 times 1 over here. This is again 1. And 2 times 1. You see? So we have another 2 of 2 times 1. Another 2 rectangles right here on this and this one. 2 rectangles that are 2 times 1. So it's 4 centimeters squared. Okay, so right now I found all the stuff in between, but now I have to find the front and the back. Now for the front and the back, you have to cut it. You have to kind of understand that if this is the front, like an ugly car you drew in kindergarten, and this is 4 and this is 4, you have to either divide it like this or you have to divide it like that, right? You have to divide it somehow. And so I'm going to divide it this way. It doesn't really matter, okay? So this is going to be 4 and this is going to be 2. 4 times 2 is going to be 8 centimeters squared right here. And this is not 4, but this is going to be 2. And then this is going to be 2. This is going to be 2. And in here, we're going to, in this side right here, it's going to be 2 as well. So, oh, sorry, I moved you. Let me check. Yeah, just a little bit. It's not too bad. Let me just try to get you back where? Yeah, there we go. And I moved you again. So my feet are too big. Okay, so then we have a 2 right here. And 2 times 2 is going to be 4. So it's going to be 4 centimeters squared. So 4 times 8 is going to be 12 centimeters squared for the area of the big thing, of the big the irregular hexagon, all right? Complex hexagon, irregular hexagon. So it's going to be 12 centimeters squared. And how many of those do we have? We have 2. We already said that there were 2 of those. So 2 times 12 is going to be 24 centimeters squared. So if I did my math correctly, I should have everything I need to be able to solve this problem, which is 8 plus 4 plus 4 plus 24, or 8 plus 8, which is 16 plus 24, which is going to be 40. This is what I got for the surface area of the last one, and guess what? That is what the book says the surface area is. So in here, you have to kind of use your imagination and kind of break down into different things so that you know what you're doing, and make sure that at the end you make sure, okay, so did I have the front face? Yes. Did I have the back face? Yes. Did I have the back rectangle? Yes. Did I have the bottom rectangle? Yes. Okay, then do I have the front rectangle? Yes. What about the one directly on top of it? Yes. What about the one right next to it? Yes. And the one that's all the way in the top? Yes. So if you have all of those and then add them together, you will be able to get 40 centimeters squared. And that's it for this lesson. All right, guys. So I'll see you next week, whether in class or whether in video. But I do want to make a quick disclaimer. If we are going to keep doing the video, then what I'm going to do is I'm going to try to keep on doing the lessons every day. Because for me, it's easier for you guys to do it at home. And if at some point they say that we're going to come back to school, even if they say it's in May, I will be able to space out the tests. And that would be a lot better. Obviously, I would give you the lesson numbers and everything. But it's just so much better for you to be working on this at home and every day, just keep on doing a lesson a day, than actually me giving you a test and then doing a lesson. Because, again, if there was temptation to look at other people's tests and, some cheating involved in some way, shape, or form, at home, I think it's way harder for me to be able to control it. So I'm going to just keep on doing the videos as long as we're not in the actual physical school. So, yeah, keep looking forward to that if we are still not in the physical school. All right. But that doesn't mean that you don't have to do your work. So thank you guys for your work. And I'll see you either in school or in the channel next week. All right. Bye.